Hi, well, what we're going to work on is some graphing, and we're going to use a couple of different methods in order to graph. And that, depending upon how the equation is given, will determine which method you would like to use. Now, we've actually kind of looked at one method because there's really three, and one of the methods is to pick points and then graph those points and connect them up. Well, before we start to graph a linear equation, we want to be able to look at an equation and determine if it will be linear when you graph the solutions. Will the solutions form a straight line when you graph them? And you can look at the equation to determine that. You don't actually have to graph it to determine what it looks like when it is graphed. Are there curves in this, or is it just a straight line if it's linear? Well, we're going to go back to our templates here, our forms. This one is the slope-intercept form, and our other one was the point-slope form. And we'll look at those and kind of look to see the characteristics of the x's and the y's, so that when we do look at any equation, we can say, yep, that'll form a linear equation. That's our linear graph. And let's look at an example. Let me come up with one. All right, and here, y minus 6. We'll just slope x minus 2/3. Not too much fun to graph that, but with the fractions, but it could be done. All right, so again, looking at the characteristics of these equations, the main thing are the exponents on the x's and the y's. And there are times where you may be given an equation that looks like this, equals 7. All right, and either of these, one of the characteristics about all the exponents on the x's and the y's is that they're all equal to 1. So in order to be a linear equation, one thing has to happen, and that the exponent on these variables need to be to the first power. All right, that's our first one. The next one is that if you'll notice here, we have adding and subtracting. I could even change this to addition. The x's and the y's need to be added together if you have them, or on opposite sides. If you were to subtract the 2x, it would be a minus 2x plus y. All right, so here you couldn't actually add them together if you were to bring this over. But in these cases here, the x's and the y's have to be added or subtracted, not multiplied together, which means here's an example of one that's not linear, and I'll show you what this would look like if you did graph it. This here is not linear. Another one, these are not linear. There's an example. Here, I was saying that the powers have to be to the first power. So here's an example of one. That power here is a squared. Therefore, it would not be linear when you graphed it. It would be a parabola. If I had y squared equaling maybe x squared plus 2, again, not linear, because the exponents are not equal to 1. They're a 2 or a 3 or a 4 or anything. Even if we had y equals x cubed, again, not linear, because you don't have a power of 1 here. If I have y, this one is very similar to this one in looks when you do graph it. Both are non-linear, but if I had 8 over x minus 1, okay, again, it's not linear, it's a hyperbola. All righty. So we're going to look at some examples that I pulled from another class, and we're going to determine which ones are linear given the equation, and we can kind of match it to the graph just to kind of give you an idea. Here we have some equations, and then we have some graphs that could go with those equations. Now, if you're looking at the linear ones here, the linear ones would be A is linear. It forms a straight line. The solutions form a straight line. And here's one that we haven't really talked about how to graph it, but this one here is linear. All right, B is linear. It forms a straight line. D is linear. It forms a straight line. And the H is linear, even though when I copied it, it kind of like a curve. But we have 4 linear graphs here, which means we need to have 4 linear equations right here. Now let's start looking at number 1. Would number 1 be linear? Would it be, my A, B, D, or H? And number 1 is not linear. To tell you the truth, number 1 is this one right here. And the neat thing is that this exponent has a great deal to do with what the graph looks like when you graph the solutions. Anything with an even power, 2, 4, 6, 8, has a basic shape of this. So this one is nonlinear. It actually looks like this when you graph its solutions. Let's look at number 2. Number 2, y equals 3. And you're thinking, well, it doesn't have an x. So can it still be linear if it has no x? Well, if you remember back in our other section that we did, we had y equals mx plus b. And we talked about these horizontal lines. And the slope of a horizontal line we found to be 0. Which means if I were to put 0 into here, this is gone. It's still linear, but it does not have that x. Can you have a linear function, or excuse me, a linear equation if you're missing an x? Y equals, let's say, y equals 2. Is that a linear equation? And what would that linear equation look like? Because it's missing the x, we know that the slope is 0. So if you're missing the x, the slope is 0, you know your line is horizontal. How do you graph that? And we're going to be doing this today. We'll do more examples of this right here. It's a horizontal line through the 2. So it's going to hit the y-axis at 2, and it's a horizontal line because the slope is 0. That's why you don't have an x. 0 times any number is 0, so it's just gone. Which means that you can be missing the variable. The key is that it's to the first power. What about an x? Before we go back to this little worksheet, what about the x? Let's kind of continue with this idea. What happens if you're missing the y and you have something like x equals a -1? Well, the x is to the first power, which, fits our first rule here. Well, what would this look like? Well, this is going to hit the x-axis at a -1. So if we were to plot points, which we'll do here after a bit, this is if you're missing a variable, it's either going to be horizontal or it's going to be vertical. This one hits the y-axis at 2. This will hit the x-axis at a -1. This has a slope of 0. That's why that's gone. This is undefined slope, just reviewing from our last section. It's undefined. So if you're missing a variable but the variable that's there is to the first power, you still have a line. It's still linear. It's just kind of a special case. It'll either be horizontal or vertical, depending upon what you have left, as long as those are to the first power. Which brings us to this right here. We were talking about number 2, y equals 3. It's to the first power, so we do know that it's a linear function. Well, I keep saying function. These are our functions. I just had to correct myself because we haven't talked about functions. So in equation, this one right here, it's going to be a horizontal line through the 3. This will be a horizontal line through 3. It's going to hit the y-axis at 3. The slope of this line is 0. So this one right here, the equation here, I don't know if I can, maybe I can do it in red. The equation for this one is y equals 3. So there's one of our linear equations, y equals 3, a horizontal line. We're going to graph a lot of these, and you'll get used to them. Now let's look at number 3. Well, this one right here, we have the x's in the denominator. When the x is in the denominator, it creates a place where, because you cannot put a 0 in here. So this one right here actually goes to this. All right, so this, if you have something in the denominator or you have a variable in the denominator, your graph is going to look similar to this one. This c is also that idea. So this is not a linear function. So this is not linear and this is not linear. You can't have a variable in the denominator. What about number 4? And I'm hoping that that's clear enough. I kind of had to put it up so that we could see the entire worksheet. But here on number 4, we have the x to the first, the y to the first. It's actually in the form y equals mx plus b. We know then that it will hit the y-axis at 1, and it has a slope of 2. So this one is a linear equation. All right, that's a linear equation. We have the x and y to the first power, and it's in the form y equals mx plus b. We're hitting the y-axis at 1, and the slope is positive. This one hits at 1, but the slope is negative. This one is, oh, there it is, sorry, it's up here. So this one is, it's 1 and the slope is positive. So this is y equals 2x plus 1. All right, so that one is linear. Let's look at number 5. Number 5 is also linear because we have the x has an exponent of 1 and the y has an exponent of 1. And it's in the form, I could rearrange this, y equals a negative 2x plus 1. I'm just going to swap these two. I kept the negative in front of the 2, and there's a positive in front of the 1. So this one also hits at 1, but this has a negative slope. So that's a good review of the slope. This is a linear equation, y equals mx plus b. It has a negative slope, and it's hitting the y-axis at 1. So this right here is y equals a negative 2x plus 1. Okay. Number 6 is not linear. All right, it's going to form something that looks similar to these right here. It's actually C. Again, 7, we have this square root. The square roots look like this. Okay, it's not linear. This one's not linear. Okay, this one goes here. Number 8. Number 9. Wow, another y equals mx plus b. It's in that form. So we've got power of 1, and let's see, it hits at a negative 1 on the y-axis, and the slope is positive. So y equals x minus 1 would be that equation right there. All right, so number 9 is linear. Number 10, these absolute values, when you have absolute values, it forms a V. So the absolute value goes up here with this F. And those of you that go on to 930 and 1400, you'll learn more about these patterns that they form. So you can graph these. But this is an absolute value. It forms a V. Therefore, it's not linear. One thing that's not on this worksheet, to kind of give you an idea though, was something like this here. Okay, so I didn't go over any of those, but those would actually be linear. All right, okay, hopefully you understand how to determine if a line is linear or not. Let me know if you don't. The next thing we're going to do is graph. So I've got some examples we're going to do on paper, and then I'm going to go to MyMathLab and show you that actually it's a little bit easier with MyMathLab to graph. You don't have to get out a ruler or anything. I'm going to move this down real quick, and so we can see it better. And let's graph. I've kept them pretty simple for you for the most part. In this section, the y is by itself. And then I'll give you some ideas on how to graph if the y is not by itself. But we know from the last section that the slope is 1. That's important to know. And I'm going to make it, to graph it, I'm going to make it a ratio 1/1. So if you're given a whole number, put it over 1. You'll see here why in a minute. I know that it hits the y-axis at a -2. This is y equals mx plus b. The b is the y-intercept. So I'm going to go to a -2, make my dot, and from the -2, from the y-intercept, here's your path. Rise over run. So I'm going to go up 1, that's the top number, and to the right 1. And we'll look to see if it's negative on the next one. And then you would get your ruler, and I'm just going to go ahead and draw the straightest line I can. And there's the graph of the solutions. Anything, any point on this line will work in that equation. Let's look at the other one. Let's look at 15. We need to find the y-intercept. I know the slope. The slope is a -1/2. But what's the y-intercept? Well, here you had to subtract 2, so it's a -2. Here it's +0. There, you don't have a number, which means you go to the 0. If it's not there, you just go to the 0. Now, this is a negative. It's a negative slope. So what I'm going to do is, rather than go, this is rise over run. All right, so it's a ratio. The slope is a ratio. That's why I wrote it here, so I know how far up and how far to the right to go, rise over run. Because it's negative, rather than going up 1, I'm going to go down 1. So I'm going to go down 1 and to the right 2. I'm still going to the right. So you either go down 1 and to the right 2. So you go a -1, you go down 1 and to the right 2, or you go up 1 and to the left 2. So down 1 to the right 2, or up 1 and to the left 2. One of them has to be negative, but not both. You cannot go down 1 and to the left 2, because a negative over a negative is a positive. Only one of them is negative. I generally go down if it's negative. I generally go up if it's positive, and then I always go to the right if there's room for that bottom number. So up or down, to the right, to the right. So I'll go down 1 from our 0. You start from the 0 on this one. We started from the -2 on this one. Always start from the y-intercept. So we went down 1 and to the right 2. And then, of course, it fits because we know it's falling. And there's your graph of all your solutions. Okay, let's look at 16. So we have y equals mx plus b. So we do know that the y-intercept is 3. So I'm going to go to the y-intercept. I'm going to go to 3. And there's 1 point on your graph. And again, the only time people really make a mistake is they start here on the x. This represents the y. That's the y-intercept. The slope is 1/2. This is the rise, and this is the run. So from the 3, we're going to go up 1 because it's a positive, up 1 over 2. And then we connect it up. It just takes practice. They say you have to see something 32 times before you actually remember it. And you've seen it 3 times. A lot more to go. Let's look at another one. Here, y equals a -x plus 3. Well, we know it hits at 3. That's not too bad. Well, what's the slope? What does that negative in front of the x mean? Well, the negative in front of the x, just like on number 14, it was a 1. It's not there, it's a 1. Here, the slope is a -1. So I'll put that there, but I do need to make it a fraction. I need to make it a ratio. So I put in here my whole numbers over 1. What this means is I'm going to go down 1 and to the right 1. So I went down and to the right, and it does, make sure it's a negative slope. Because it's a negative slope here, it will be falling. And when you connect the points, it is falling. And we're going to do more of these with MyMathLab. But I just wanted to get you started and do some writing here. We're going to look at graphing horizontal and vertical lines, which I kind of touched on when we were determining if they're linear. These are linear. They have an exponent of 1, a power of 1. In order to graph y equals a -3, you're missing the x, so it's not quite in the form that we like, where we've got the y-intercept and the slope. The slope is a path from point to point. That path doesn't change. It's a constant throughout the line. But here, if this is a horizontal line, so if we have y equals a -3, so y equals -3 is a horizontal line. The number in front of the x is a 0. Now the horizontal line is going to go through a -3. So you go to a -3. Okay. And this is the graph of this. So it's going to hit the y-axis at a -3, and the slope is 0. So this is if you're missing the x, because we had y equals 0x minus 3. These two mean exactly the same thing. 0 times x is just 0. So you can actually get rid of that and write it like this. This means when a variable is missing is that the x can be anything as long as the y is a -3. So if it's still a little confusing here, you can say, okay, x is gone in that equation, so we can make the x a 1. Y has to be a -3. X can be 2. Y has to be a -3. X can be 5. Any number, I'm just picking numbers. Y has to be a -3. If you plot these numbers, 1, -3, 2, -3, 5, negative, and if we were to connect them up, you form a horizontal line. So you can think of it as points. You can think that, okay, this is a horizontal line and it's going to go through the -3, because we want all our y's to be a -3, which they are. 4, -3, -1, -3. All right, what happens if we're missing the y? Well, here, this is going to be a vertical line. And what this means is that the x has to be 4. And since the y is missing, it can be anything. It could be a 0, it could be a 1, it could be a -1, it could be a 2. All right. So the y can be anything. It's gone. It's missing. So it doesn't matter what it is. As long as the x is 4, it fits. If you were to put this in, then the left always equals the right when you put those points in. We're going to graph these points so you can see that this is going to form a vertical line this time. 4, 0, 1, 2, 3, 4, 0. I'm not going to go up any. 4, 1, 4, 1, 4, -1, 4, -1, 4, 2, 4, 2. If we connected these up, we now have a vertical line. It hits the x-axis at 4. The slope of this one is undefined. So again, we have horizontal through a -3 and a vertical through the 4. I have some other ones, so other examples. I don't, but we'll look at some with the Pearson. So I'm going to get Pearson up real quick. All right, so I have a homework example up here, and this is the homework example number 5. The first 4 deal with is this linear or not? So you guys can look at those. But here we want to graph the equation y equals a negative x. So what you'll do is I would come over here and do this pop out. And we want to graph a line. This is going to be a linear equation, y equals a negative x. So you have to tell MyMathLab the basic shape. And this is going to be a line. So we're going to push line here. And you'll go over and you're going to click on the y-intercept first. Well, this is a minus x plus 0. So I'm going to go down to 0. And you know where you're at because if you look at the top right in this pop-up, it has the coordinate 0, 0. So as I move that around, see how those ordered pair change. But I want 0, 0 because it hits the y-axis at 0, then click. Now from there, I know my slope is a negative 1 over 1, which means I'm going to go down 1. So you can watch your coordinates if you can't watch the graph. Go down 1 and to the right 1. And so you're down 1 and to the right 1. Yep, there we go. So you're at 1, negative 1. And click, and there's your line. So then, once you have this, you press save. And it'll save it, and then you can check your check answer. So there's one of your graphs, and we'll do a few of these. Yay, I liked it. Okay, let's do this one right here. I'm going to do the pop out here. And it's linear. It's y equals mx plus b. It's in our nice little form. This time I'm going to go to a minus 3 because that's the y-intercept. So I take this and I'm going to go down to a negative 3 on the y-axis and click. From there, I have 2 over 1. So put your whole numbers over 1. So the slope is 2 over 1. So I'm going to go up 2 from the negative 3. I'm going to go up 2 and over 1. So I went up 2 and over 1. And it looks pretty good. If it doesn't like it, then we'll just come back and try it again. Now you can always, if you make a mistake, you click, you can always clear it and then press line and do it again. So you can clear, if you accidentally clicked on the wrong one and it made your line for you, you can clear it and then push a line again and do it again. So we'll save this. Looks like our nice little line there. Let's check it. And it liked it. Okay. Here we go. A lot of these are positives. So that's fine. That's fine. Otherwise, we'd be going down and to the right. But we're going to go to a negative 2 on the y-axis. So I want a line. So I push line. I'm going to go down to a negative 2 right here. Click. From there, I'm going to go up 4 because it's 4 over 1. I'm going to go up. So you do need that bottom 1 because that tells you to go to the right. If you have a whole number like 4, put it 4 over 1. If you had a 5x, 5 over 1. We'll go up 4 from our negative 2. So 1, 2, 3, 4, and to the right 1. Don't forget to go to the right 1. You've got a vertical line, and it's not a vertical line. Great. I don't think I need to clear it and start again. I'll just press save and check my answer. Oh, great. Awesome. Oh, let's try this one right here. Pop it out. Y equals 2/9 x. It's a line. The x's and y's are to the first power. So, oh, look at this. Wow. That doesn't look fun, but that's all right. We have a line. I press line. Where do we go on the y-axis? There's no plus anything, which means you go to 0. So we're going to go to 0. We're at 0, 0. Those ordered pair in that top right of my pop-up. Oh, I moved over. Good. 0, 0. Click. We're going to go up 2 and to the right 9. So I'll go up 2 and each little half a tick mark is 1. So 1, 2, I went up 2 and now I'm going to go to the right 9. So I'm going to go to the right over to the 9, which there I am, 9, 2, up 2 and over 9. You know, and if you push on it and it doesn't like that, you can clear it. Save it and check it. Okay, good. All right. So again, you know, the slope is a -1. You'd go down 1. You go to the 19, and you know, see, it's kind of helpful doing graphing with Pearson. It's not horrible. All right, but I'm hoping you kind of understand how to use the pop-up and how to graph those, because we have one more thing to do, and that's a different way to graph if it's not y equals. We have another one that you can use to graph these. All right, another method of graphing other than the y equals mx plus b to find the y-intercept and then use the slope, which is a path from point to point, to find another point. There are times when you're not given the y equals mx plus b form. So you can see if you can use what's called the x and y-intercept method to graph it. Now we're going to look at finding what is the x and y-intercepts. We'll look at, given this line here, what would be the x-intercepts, what are the coordinates of the x-intercept, and then what are the coordinates of the y-intercept. And we're going to take this idea and apply it to graphing, given a certain equation. Well, your Pearson is going to ask you for the y-intercept, the ordered pair of the y-intercept. Looking at this, the y-intercept is where it hits the y-axis, so don't get those two confused. This line right here is hitting the y-axis at that point. What are the ordered pairs for that point? Well, I know that the first number in our ordered pair has to do with how far you are along this x-axis. It's the x coordinate. And it looks like we're at 0 here, which means that the y coordinate is 0, 1. So the y-intercept, excuse me, not y coordinate, the y-intercept is the point 0, 1. Any point along here, we've kind of talked about this before, all of these points, the x coordinate is 0. The x coordinate is 0 whenever you hit the y-axis. All of those have an x coordinate of 0. Actually, put another 0 there. Now the y value changes. Here it's 1, here it's 2, here it's 3, 4, 5, and 6. But a really important concept to remember is that when you want to find the y-intercept, the x is 0. What happens if you want to find out where it hits the x-axis, or what we call the x-intercept? This is the x-intercept. That's where it hits the x-axis. What are the coordinates of that point? Well, 1, 2, 3, 4, 5, 5, and you're not going up or down, so the y value is 0. In fact, any point on the x-axis, here you go to the right 1 and up 0. Here you go to a -1, 0. I'm kind of writing those little, aren't I? You can read them. Here, this is a -2, 0. This right here would be 3, 0. So if you'll notice, when you want to find the x-intercept, the y is always 0. Whenever you hit this x-axis, your y coordinate will always be 0. So when you want to find the y-intercept, the x's are 0. When you want to find the x-intercept, the y's in the equation are 0. Just think of it as opposite. Y-intercept, x0. X-intercept, y0. It's always going to be the opposite, because I'm going to ask you to find these given the equation. But going over here, the x-intercept, this one hits at the coordinate 5, 0. The y-intercept, the x is 0. The x-intercept, the y is 0. And this is a really nice method if you're not given the equation in y equals mx plus b form, which we were graphing before. Okay, let's look at another one. This idea, and then I'll give you an equation and ask you for the y-intercept and the x-intercept. Okay, here, what are the coordinates of the y-intercept as an ordered pair? Well, where does it hit the y-axis? It hits this y-axis right there. What are the coordinates of that written as an ordered pair? Well, you always, how far along here did you go? And we know that when you hit the y-axis, the x is always going to be 0. You're not going right or left. And you went down -2, or you went down 2. So our y-intercept is 0, -2. That's where it hit the y-axis. Where is it hitting the x-axis, the x-intercept? Well, that's right here. And I know that when it hits the x axis, the y is 0. X, the y is 0, the y-intercept, the x is 0. The opposite variable is 0. The way to remember it. But exactly what are the ordered pairs here? Well, this is the ordered pair 1, but you're not going up any. So it's 1, 0. So they're going to ask you to find the x and y intercepts given the graph. And again, you just look at it and find those coordinates. Remember that the coordinate, the x coordinate here is 0 when you're finding the y-intercept. The x-intercept, the y is 0. And have the opposite. Okay. But what happens if you're given the equation? How do I find the x and y-intercept? To find the y-intercept, we know that the x is 0. So here we're just going to make the x 0 and solve it for y. So when you want to find the y-intercept, the x is 0. In other words, that's gone, right? Because 3 times 0 is 0. So it's gone, which means we need to solve this equation. Divide by 2. So the y-intercept, it hits the y-axis at 12. But they want that written as an ordered pair. Well, we know that the x is 0. That's what we made the x 0 to find the y-intercept, 12. Yeah. Some of you can probably even look at that. So you don't have to go through this whole process. You just know, okay, to find the y-intercept, x is gone. You divide by 2, and you get 12. All right. To find the x-intercept now, I'm going to make the y as 0. So now, to find the x-intercept, the y is 0. So now the y is gone. Oh, 24. I was solving it in my head. Divide by 3, x is 8. So the x-intercept, the x coordinate always goes first. The y coordinate, which we know is 0, goes second. So there's the x and y intercepts. Okay, let's see if we have another one to try. We do. We have actually 2 more. Okay. Let's find the y-intercept for this equation. To find the y-intercept, I'm going to make the x as 0 and then solve it for y, which means I'll have 3 times 0. To find the y-intercept, where it hits the y-axis, the x is 0. 3 times 0 is 0, it's gone. Divide by a -4, because a negative over a negative is a +1, which is what we want. 12 over a -4 is a -3. So the coordinates, where it hits the ordered pair, where it hits the y-axis is 0. We always put the x value first, -3. That's where it'll hit the y-axis, 0, -3. Okay, let's find the x-intercept of this equation right here. To find the x-intercept, I'll make the y 0. And that's gone. So we divide by 3. X equals 4. So the ordered pair, the coordinates of this point where it's going to hit the x-axis, we put the x first in our ordered pair, and the y value is 0. Okay, all right. Let's look at number 22. 22 is a little different. We're missing a variable. So you might want to think, wow, what does this look like? And this, maybe making a sketch of this might help you, because it's not so easy to make the x 0 because it's gone. And then, make the y 0. It's going to be a little bit tougher. So I'm going to sketch it here. I know this is a horizontal line. The slope is 0. It's going to hit the y-axis at 4. So we have the y. It's going to hit the y-axis at 4. And it's a horizontal line. Okay. So what is the y-intercept? Let's look at that. Does it hit the y-axis? Sure it does. It hits the y-axis at 4, which means, and the x-coordinate is 0. Okay. The horizontal line through 4, it hits the y-axis at 4. What's the x-intercept though? Will this ever hit the x-axis? And no, there is no x-intercept here. And if you're given a vertical line, instead of y equals 4, what if it was x equals 4? And again, I'm just, kind of going through a little bit of these, all these ideas here. This is going to be a vertical line through 4, 1, 2, 3, 4, even though I'd like to spend more time on these. At least you'll have a rough idea when you run into this equations and things and graphing in your other class. Okay, this is a vertical line through 4. It's an undefined slope. It hits the x-axis at 4. And what is the y-intercept? Well, here there is no y-intercept. Better kind of carding that off. And what's the x-intercept? The x-intercept is 4, 0. But there is no y-intercept. So if you're missing a variable, you're going to be missing an intercept, either one or the other. Okay. Well, now we're going to use this idea to graph. Given an equation like number 23, it looks like this. And we're going to use the intercepts to graph the equation. It's not in the form y equals mx plus b. So we don't know where it hits the y-axis right now. And we don't know what the slope is. We'd have to solve this for y in order to determine what the slope is. What we're going to do to graph this is we're going to use intercept, the intercept method. To do that, here we'll find where it hits the y-intercept first. And then we're going to put that here, and the x-intercept. And then we'll put our point here, and then we'll just connect them up. Well, here the y-intercept, x is 0. So to find the y-intercept, x is 0. So 2y equals 6, that's gone. Divide by 2, y is 3. It will hit the y-axis right there. So you would take your cursor and put a point right there. Then the x-intercept. How do you find the x-intercept? You make the y 0. So we go to our equation. And we solve that. That's gone. Divide by 3. X equals 2. So it's going to hit the x-axis at 2. You put your cursor there, and my math lab will just draw this line in. So you put a point there, and then you put a point right there on 2, and it'll draw it in for you, and then you save it. But that's how you can use the X and Y intercepts to graph. Let's do some other ones, and then we can always look maybe at some, I can get MyMathLab up, but this being able to do it on paper is a little bit easier to explain it to you. Okay, right now we're going to find the X, using the X and Y intercepts, we're going to graph the equation. We're going to find the Y-intercept, and we're going to find the X-intercept to graph it. Again, this is just another form. And another thing is you don't want to use this method. The only time you want to use this method is if both of these numbers that are in front, these are called the coefficients, the 1 and the 4, go into this number evenly. They both of these need to go into this number to use this method. Otherwise, you just need to get the Y by itself and try using that method. First off, the Y-intercept. So to find the Y-intercept, we make the X 0. So we have 0 plus 4Y. I'm hoping you're catching on. And if you are, you can always quit watching. But now we've got 4Y equals 8. Divide by 4. Y is 2. It will hit the Y-axis at 2. There's one of our points that you would put with your cursor. X-intercept. To find the X-intercept, the Y is 0. So we have X plus 4 times 0. That's gone. It will hit the X-axis at 8. And then MyMathLab will, we'll draw a straighter line than I did. Okay. All right. Let's try another one. So we're finding the X and Y intercepts to graph. Here, again, -1 goes into 8, and 4 will go into 8 twice. No fractions here. So we'll use this method. Besides that, they told us to use the intercepts. So we're going to find the Y-intercept. We're going to make the X 0, and then we'll find the X-intercept. We'll make the Y 0. It's always the opposite. Variable is 0. To find the Y-intercept, we'll have a -0. Well, a -1 times 0 is still 0. So 4Y equals 8. Divide by 4. Y is 2. You hit the Y-axis at 2. Now let's do over here. Make the Y 0. So we have a -X. That's gone. And divide by a -1. You do need to get rid of that negative, and it's actually a -1. We just don't put in our ones. So we divide. A negative divided by a negative is a positive. So this will be a +1. So if you do have that negative, you will need to do this step. So our X-intercept is a -8. So there's your graph. All right, let's do another one. And then maybe that will be it. Yeah. All right, we'll do one more just in case. So we have the Y equals mx plus b method, where you go to the b on the Y-axis. Let me focus this. And then the slope is a path, rise over run. Or you can use this method, and you can always plot points, which is kind of what we did at the beginning. We picked some X's and found some points on the graph. Right, here we go. Y-intercept. We make the X equal to 0, and then the X-intercept. We'll make the Y All right, so y-intercept, x is 0, x-intercept, the y is 0. Okay, so we have here the x is going to be 0, so we have 3 times 0. It's gone. Now it's easy to solve. Y equals 6. There's our point, 6. To find the x-intercept, now again, I'm using this method because I should back up. You can take 6 divided by 3 and get a whole number, and 6 divided by 1 and get a whole number. Otherwise, you don't want to use this method. Y is 0. So that's gone. I put a 0 in for the y. Divide by 3. So 1, 2. So here it's going to hit the x-axis at 2 and the y-axis at 6. So you would put your cursor here, then come over to the 2 and put the cursor, put your point in, and you have a graph here. So this one, the slope would have been a negative number. All right. Now, in order to use the slope-intercept method, I'm going to take this and I'm going to use the slope-intercept method. In order to do that, we have to have the y by itself. So what I'm going to do to get the y by itself is I'm going to subtract 3x. Let's say I didn't want to use this method. So I have y equals, oops, I move this over, a negative 3x plus 6. I put this first. I can't combine them because the 6 doesn't have an x. So they stay separate, which means I go to the 6 on the y-axis, make a dot. Then I'm going to go down 3, that's the slope, and over 1. So our slope is a negative 3 over 1. So I'll go down 3, 1, 2, 3, and over 1. So you would have come up with the same line. It's just that sometimes it's easier to actually use this rather than to get the y by itself. But either method, you're going to end up with the same line, the slope-intercept or using the x and y intercepts. I just want you to be good at both of those methods here. And then also the plotting of the points, which we did in the first section, where they give you different x's and you find the y's, or they give you a y and you find the x. And then you can plot those points and connect them up. All right. Wow. That pretty much does it for this section on graphing. If for some reason something seems really confusing to you, let me know. I can go through it. We do cover a lot of material very quickly. And if it's not a review, if you haven't seen this stuff before, you'll probably need to contact me so I can help you out. All right. Bye-bye.